Good afternoon, students. Once again, I welcome you all for this session. Okay, so in the previous class, we have studied the moment. Okay, so definition of moment, then how the moment will be calculated, and other things related to the moment we have studied. Next, we'll move on to the another important aspect of this mechanics, that is we're going to study two definitions. One is resolution of forces, then second one is composition of forces. Okay, so already you know that what you mean by a force. So force is nothing but is an external agency which will going to change the state of the object. Okay, so when force is acting on a body, the behavior of the body is going to change, and by applying the different forces we are going to study the behavior of the body. Now one term is called, that is a resolution of forces, or that is resolving the forces. Then what do you mean by resolution of forces? Now see, there is a force acting at point O now. So this is x axis, this is y axis. Let us take there is an inclined force F, okay, which is making an angle theta with x axis. Now this is a single force. Okay, so instead of single force, I can find out, okay, I can find out number of component forces of same force F. Okay, so instead of single force, I can split up this single force into along x direction and along y directions. So if you resolve this force, or if you take this force along x direction, then this is Fx and then this is Fy. So Fx and Fy are nothing but the component of forces, right? Fx and Fy are the component of forces, and they will be having the same effect as that of this single force. So instead of single force, I can consider there are two forces, one along x axis, that is Fx, and one along y axis, that is Fy. So the process in which the single force can be split into two forces, that is Fx and Fy. So this process is called as resolution of forces, or resolving the forces along x direction and along y direction. So remember, resolution of force is nothing but it is the process in which single force can be split along x axis and along y axis, and these two components, that is Fx and Fy, these two components will be having the same effect as that of single force. The effect will not going to change. Okay, so this process, right, making a single force into number of forces is called as resolution of forces. Okay, right. Then what about this composition of forces? Composition is nothing but opposite of this resolution. Resolution means what? Single force is divided into number of forces. But composition is nothing but combining. Composition, what is the meaning of composition? It is a combination, combining. Okay, so now again take the example here. Okay, there are four forces, F1, F2, F3, F4, like this. So there are number of forces acting at point, single point. Okay, then I don't want these all these forces. Okay, what I'm going to do? I'm going to find out what is the effect of single force when I combine F1, F2, F3 and F4. I'm going to combine all these four forces and I can find out a single force. Okay, and that single force will be having the same effect as that of individual forces. Then how to combine, we're going to see, okay, in the next session. But right now remember, when number of forces are acting and these number of forces can be added, and it is possible to find out a single force, and that single force is called as resultant. I hope you already studied in your PUC level what I mean by a force and a resultant. Okay, so combining number of forces and finding out a single force is called as resultant. So this resultant will be having the same effect as that of number of forces, and resultant is denoted by R. Okay. So when there are number of forces are acting, combine them and find out a single force. So this process is called as composition. So composition is addition of number of forces and finding single force, and that single force is called as resultant. So this is composition. What is resolution? Resolution is single force is divided into number of component forces, that is called as resolution. So try to understand these two terms, important terms. Okay, right. Then how to add, then how to split, we're going to see in the next session. But right now remember these two definitions. Resolution, that is single force, can be split into number of forces, component forces, usually along x-axis and along y-axis. Then composition, combining the number of forces, and finding out a single force, that is called as resultant. This process is called as composition. Then how to find out the composition, or how to find out this resultant? Now let us take this process only, right? How to find out single resultant? When number of forces are given, how to find out a single force, that is resultant, that we're going to see. There are various methods. Okay, so various methods can be used to find out the resultant, okay, by combining the number of forces. Even in your PUC level, you have studied parallelogram law of forces, triangle law of forces, polygonal law of forces, right? So all these laws are used to find out a single force, that is resultant. So when there are number of forces are acting, yes, you can find out the single resultant by using parallelogram law of forces, or triangle law of forces, or polygonal law of forces. Okay, so now let us take one by one. First take parallelogram law of forces. Okay, so this is the basic law, okay, used in engineering mechanics for finding out the resultant of concurrent forces. Now whether all these are concurrent forces, see F1, F2, F3, F4, because all these are passing through a single point, the line of action of all these passing through a single point. So this force system is called as concurrent force system. Okay, so how to combine these four forces and finding out the resultant? Using this parallelogram law of forces. So this is a graphical method. Okay, so as already you have studied in your PUC level, I think in practical also you have done this experiment, that is finding out the resultant. Okay, so using that parallelogram law of forces or triangle law of forces. So this parallelogram law of force is the basic law used in engineering mechanics for finding out the resultant of concurrent forces, and important is this is a graphical method. Okay, right. Next, now take an example. There are two forces. Let us consider two forces first, F1 and F2. So this is F1, this is F2. So the angle between these two forces is theta. So these two forces F1 and F2 acting at a point A. Okay. Now I will going to combine these two forces F1 and F2, and I will going to find out a single resultant. Okay, single force I will going to find out. Then using this parallelogram law of forces, what we are going to do? So you are going to draw parallel to this. Take a sheet of paper. Okay, on that mark point A. So mark point A. From A you draw parallel line that represents, that you can name them as AB. So AB line indicates what? The force F1. This. Okay, AB line indicates force F1. Then from A, same point from A, draw parallel to this another line, that is AC. Okay, AC will going to represent what? Force 2. So there are two lines now. AB is nothing but force F1, then AC is nothing but force F2. Now complete the parallelogram now. Parallel to this, okay, parallel to AB, draw a dotted line here. Then parallel to AC, draw a dotted line here. Now A, B, D, C. Is it parallelogram? Yes. ABDC is a parallelogram. Now, what this parallelogram law states, okay, it states that if two forces, okay, acting simultaneously on a body at a point, and these are represented in magnitude and direction by the two adjacent sides of a parallelogram. Okay, so AB is one side, AC is another side. So AB and AC are the two adjacent sides of a parallelogram, and they are representing force F1 and force F2 in magnitude and direction. Then joining this, completing this resultant, join AD. Join AD. So AD is called as what? Diagonal. So AD is diagonal of this parallelogram, right? So what this law states? It states that if two forces acting simultaneously on a body at a point, and these are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant, okay, the resultant of this F1 and F2 is represented in magnitude and direction by the diagonal of parallelogram. So draw the diagonal, and diagonal itself is nothing but a resultant R. Okay, so diagonal of a parallelogram which passes through the point of intersection of these two forces. So it is going to pass through from A only, it is, which passes through the point of intersection of two sides representing the force. So draw AB line which represents F1, draw AC line parallel to these two lines AB and AC. So they represents what? F1 and F2. Then complete the parallelogram, then draw the diagonal. So the resultant of F1 and F2, when I combine F1 and F2, the resultant R will be what? Diagonal AD. So it is important in exam, they are going to ask, explain parallelogram law of forces. So just draw the line, draw the sketch, then write the statement. So in figure, F1 and F2 acting on a body at a point A simultaneously. Then to get the resultant of these two forces, parallelogram ABDC is constructed. Then according to this law, diagonal AD is nothing but the resultant of these two forces. So this is called as parallelogram law of forces. Okay, similarly another method can be used, that is a triangle law of forces. That is triangle law of forces. So what is states that? It states that if two forces, okay, if two forces acting on a body are represented one after the another by the sides of a triangle. Now see, again same two forces will going to take. So write, draw parallel to this, mark point A, draw parallel to this line, that is AB. So AB represents force F1. Then one after the other, that is important here. Now from B, not from A now. Now from B, parallel to this force F2, parallel to this force F2, draw from point B. So that will, BC will represents what? F2. Now AB and BC, okay, AB and BC are the two sides of a triangle. Okay, AB is one side, then BC is another side. So AB represents F1 force, BC represents F2 force. Okay, then completing the triangle now. AB is one side, BC is another side, then join third side of a triangle, that is AC. So the third side of a triangle AC is representing what? Resultant R. Okay, so the resultant of F1 and F2 is the third side of a triangle AC. So here same it is. Here what you are taking? Two adjacent sides of a parallelogram, right? But the forces are not taking one after the other. It is starting from A only. So it is AB and it is AC. But here AB, then from B it is BC. This is F1, this is F2. Now F1 and F2 are two sides of a triangle. That is AB and BC are two sides of a triangle. Then the third side AC is nothing but the resultant. So this is known as triangle law of forces. When two sides are drawn one after the another, third side is nothing but the resultant of two forces. Okay, right. So this is triangle law of forces. So remember this first one, parallelogram law of forces and triangle law of forces. These two methods are used when there are only two forces. Okay, when there are two forces, yes, you can combine them and you can find out the single force, that is resultant, either using parallelogram law of forces or triangle law of forces. But when there are number of forces, now let us take an example, right? So there are four forces, that is F1, F2, F3, F4. Okay, so when four forces are acting, right, we cannot use these two methods, that is we cannot use parallelogram or you cannot use triangle law, but basic concept will be remains same. So how to combine these four forces and how to find out a single resultant force? Okay, so again let us take this point A, mark point A, then draw parallel to this, draw line parallel to force F1, that is line AB. Line AB represents force F1. Next, from B, draw a line parallel to this force F2. Here only, just like a triangle. Okay, triangle only we'll going to use here. So AB represents force F1. Then from B, draw parallel to this F2, like this F2. So that is BC. So line BC indicates force F2. Now AB and BC. AB and BC are two sides of a triangle. Two sides of a triangle. Then if I join AC, then this is the resultant of what? It is, I am writing here R1, not R. Right? R1 is what? Resultant of F1 and F2. When I combine F1 and when I combine F2, then I will going to get a resultant R1. Okay, resultant of F1 and F2 is R1. Okay, next from C. Okay, from C again draw parallel to this force F3. Okay, draw a line indicates CD. So CD is representing force F3. Okay, then again there are two sides now, right? R1, okay, R1 is one side, then this F3 is another side, or AC is one side, then CD is another side. Then join AD. Again this will go into ACD will be the triangle. Okay, in that AC is one side, CD is another side. Then the resultant of R1 and F3. Okay, resultant of R1 and F3 is what? R2. This joining the third side of a triangle. So resultant of R1 and F3 is R2. Then remaining last from D now. From D draw parallel line to this. Okay, that indicates DE. Okay, DE indicates force F4. Now again there are two forces, that is R2, that is resultant R2, and this F4. Okay, so these AD and DE are the two sides of a triangle. Then joining the third side. Now we have started from A. So joining A to E. So this will be resultant of all these four forces, that is F1, F2, F3, F4. Okay. So just observe here. AB, BC, CD, DE and EA. So it is a polygon. Right? 1, 2, 3, 4, 5. Okay. So 5 sides means it is a polygon. Right. So we have started from A. Draw parallel line. That is AB representing F1. Then from B only draw this F2. Okay. Then AB and BC, right, are the two sides of a triangle. Then the third side AC will be the resultant of F1 and F2. I can write it as R1. Then R1 and this CD will be the two sides of a triangle. Then the third side AD representing resultant R2. Then R2 and DE representing F4. So the third side joining A and E will be the final resultant of all these four forces. So this represents a polygon. Okay, so using this polygonal law of forces, yes, I can find out this resultant. So when two forces are acting, yes, you can use a parallelogram law of forces or triangle law of forces. But when number of forces are acting, so at a time you have to take two forces simultaneously, then go on finding out the resultant. So this is called as polygonal law of forces. And what is this law states? It states that if a number of concurrent forces acting simultaneously, so these are the number of forces acting simultaneously at point A on a body, are represented in magnitude and direction by the sides of a polygon. Okay, these are the sides of a polygon taken in order, that is from 1 to next from AB, next from you have to start from B only, BC, then from CD, DE, then joining this or closing the polygon is the resultant order. Then the resultant is represented in magnitude and direction by the closing side of the polygon. So taken from first point to the last point. So this is the resultant of F1, F2, F3 and F4. So remember, these are the three important laws can be used to find out the single force. That is, when you are combining the number of forces and you want to find out a single resultant force, then you can use either polygonal law of forces, triangle law of forces, or right. So these are the different laws can be used. Okay, so three laws you have studied. Okay, one is parallelogram law of forces, triangle law of forces, then polygonal law of forces. But remember, all these three laws representing graphical method. Okay, so you can use the graph papers or drawing sheets. On that you can try this exercise. Okay, but we don't want graphical method. We actually wanted to know analytical method, right? So what is the right equation? What is the equation used when the number of forces acting on a body, and to find out a single resultant, what is the equation we can use? So that is called as analytical method. So in the next session we are going to start with the analytical method of finding the resultant force. Okay, I hope you understood this simple concept, right? So if any doubts, feel free to ask me or Tejaswini madam. Okay, so in the next session we'll come up with the analytical method. So thank you very much for attending this session. Have a good day.